friends, my name is Pooja Arora and I am giving you video lectures on the subject of discrete mathematics, and our today's topic is equivalence relation. The definition of equivalence relation says that a relation is equivalence if it satisfies three conditions. The very first condition, if it is reflexive, that means A belongs to R for all A belongs to capital A. And the second condition says that relation must be symmetric. Symmetric is if AB belongs to R, then BA must belongs to R for all AB belongs to capital R. And the third condition is that the relation must be transitive. Transitive means if AB belongs to R and BC belongs to R, then AC must belongs to R for all ABC belongs to capital A. Okay, before discussing about equivalence relation, you must understand these three type of relation in depth. So I have already prepared a video lecture on these three topics under the name type of relation in my YouTube channel. So if you are not very sure about these three definition, firstly go and watch that video. Only then you can understand the concept of equivalence relation. At this moment, I'm assuming that you already have a basic knowledge about these three type of relation. So let's move to an example of equivalence relation, and we will going to check if the relation is equivalence or not. So this is my first example given, and I have to check if it is equivalence or not. Very firstly, I'm going to check if the relation is reflexive or not. For this, I have given a set of capital A, that is we have three elements, that is A, B and C. Okay, so I'm going to check if the relation is reflexive. So I have to check for reflexivity for three elements, that is AA, that is BB and that is CC. So when I examine the relation, I got AA, I got BB and I got CC. For all three elements, the example satisfy the condition. So we can say that this example is reflexive. So it satisfies my first condition, that is the relation is reflexive. Let's check the second condition, that is symmetric. The symmetric condition says if AB belongs to R, then BA must belongs to R. So let's just check. We got AB, but in the relation I am not seeing any BA here. So the relation is not symmetric. So it is not symmetric. For the sake of completion, let's check if it is transitive or not. So if we check the condition of transitive, that is AB belongs to R and BC belongs to R, then AC must belongs to R. So here I got AB and BC, then we have to check AC, and AC is here. Till now the condition satisfy, and let's move to the second pair, that is I got AC, I got CB, then AB must belongs to R and AB is also here. So till now the condition satisfied for the transitivity. But let's move on and check other pairs also. So as we move forward, we got a pair that is called BC and we got a pair that is called CA, and we have to check if BA belongs to R or not according to the definition of transitivity, and there is no BA in the relation, so we can say that the relation is not transitive. So as you can see that the given example is reflexive, but it is not symmetric and it is not transitive, so it is not equivalence. Okay, so let's just check the smallest example of equivalence relation in the next section, that is AA, BB and CC. By seeing the example, we can clearly see that the relation is reflexive because we get all the pairs here. Okay, check if it is symmetric or not. Yes, it is symmetric. Why so? Because the symmetric condition says if AB belongs to R, then we have to look for BA, and here I don't get any AB, so I don't have to look for BA also, and we can directly say that the relation is symmetric. And the same way we can say that yes, the relation is transitive. because the condition of transitivity says if AB belongs to R and BC belongs to R, then only we have to look for AC. Here I am not getting AB, I am not getting BC, so I don't have to check for AC, and I can directly see the relation is transitive. So I can say that this given example is an equivalence relation. So this was my first example of equivalence relation for the understanding and the revision of these three type of relation. Now the question come in the word format. So we will take an example from that. You can note it down if you want. So here we have the next example, that is we have to prove that the given relation is equivalence or not. The relation says on the set of integer, z means integer. The definition of relation is defined by xy, sorry, we have to say the variable names are same. AB belongs to R if A is congruent to B mod n, or A minus B is divisible by n. Actually these two definitions are same. You can get it in either way in your question paper. Either it is written as A is congruent to B, or it is written as A minus B is divisible by n. That is the same thing. So we have to check if the given relation is equivalence or not. So very firstly let's start with the first condition, that is reflexivity. So we are going to check if the relation is reflexive or not. So I hope you remember the condition of reflexive, that is A belongs to R for all A belongs to capital A. According to the definition, I am putting both the variables as A. So what I get, if I have to check if A minus A is divisible by n. So as we know, A minus A is equal to 0. And 0 is divisible by every number in mathematics. We know that, so we can say that the yes, as you have to write it here, since 0 is divisible by every number, so we can say that the relation is reflexive. So here we check for the reflexivity, and the second condition says symmetric. So you know the condition of symmetric, that is if AB belongs to R, then B must belongs to R. That is the condition for checking the symmetric condition. If AB belongs to R, that means B must be belongs to R. So let's check. If AB belongs to R, that means A minus B is divisible by n. If A minus B is divisible by n, I will get an integer. Any integer, I am naming it P. Okay, and by this statement we are going to check if B minus A is divisible by n or not. So I'm just changing the order of the variable, nothing else. A minus B and B minus A, as you know that if I change the order, I will get a negative value. So I can clearly say yes, it is divisible by n, only with a negative sign. It doesn't impact the value. So we can say that yes, it is symmetric. We have proved that the relation is symmetric. And now the third condition, that is transitivity. Transitivity says if AB belongs to R and BC belongs to R, then we have to check if AB belongs to R and BC belongs to R, then we have to check if AC belongs to R or not. That is the condition for transitivity. Let's check if the relation is transitive or not. Okay, so my relation was A minus B is divisible by n, and if I take the first statement, that is AB belongs to R, that means A minus B is properly divisible by n, and I'm getting an integer value, that is P. That will be my first statement. And my second statement will be BC belongs to R, that means according to the definition it is say B minus C is divisible by n. So B minus C is properly divisible by n, and I'm getting an another integer, that is Q. by assuming that these two statements are true, we have to prove if AC belongs to R or not. So we have to check if AC belongs to R. That means if A minus C is divisible by N or not. That we have to going to find out. Okay, so what we can do, we can write this statement as A minus B is equal to NP and B minus C is equal to NQ. Now we have two statement A minus B and B minus C. What I am going to do, I am just simply adding these two statement, equation 1 and equation 2. What will I get? On the left hand side, I will get A minus B plus B minus C, and on the right hand side I will get NP plus NQ. So here I come, A minus C is equal to NP plus Q. So I'm already getting the third statement, that is A minus C is divisible by, and I'm getting P plus Q, that will be another integer R for me, and we can clearly see that A minus C is divisible by N. So we can say that the relation is transitive. Hence we see that the relation is reflexive, it is symmetric, and it is transitive. So we can say that the relation is an equivalence relation. Hope you got the concept. You can note it down, this example, and then we will move forward to the next example. So here we have the next example, that is relation R on the set of n cross n, that is natural number, and the relation says ABRCD is equal to A, given by AD is equal to BC for all AB, CD belongs to n cross n. Here what is the trick? Actually till now we are seeing the example with one variable, that is in the last example you can see the example is written as A minus B is divisible by n, and here I am getting a relation on the pair of elements. That means we are working on the pair now, that is AB, CD belongs to n cross n, and the pair relation definition is said AD is equal to BC. How we get this definition? We are just taking the first element of the first pair, last element, second element of the second pair, and multiplying these two elements. And on the right hand side of the equal to, we are getting second element of the first pair and first element of the second pair, and multiplying these two elements. By this operation we are getting this relation. So we have to check if the relation is equivalence or not. Let us start with reflexive condition. So very firstly we have to check if the relation is reflexive or not. So we know the condition of reflexive, but here we have to put the condition of reflexive in the pair format. So what will be the definition will be, it will be AB comma AB belongs to R. The relation will be reflexive if AB comma AB belongs to R. That means the same pair will relate to the same pair, then we can say that the relation is reflexive. Getting the point? So according to this definition, we are going to multiply our first element of the first pair to the last element of the second pair, that is AB also. And on the right hand side, we are multiplying the last element of the first pair and the first element of the second pair, and we are getting BA. So we have to check if it is equal or not. Since we all know that the multiplication is commutative, so AB and BA are equal, so we can say that the yes, it is reflexive. The condition satisfied and our relation is a reflexive relation. Now we have to check for the second condition, that is symmetric. We have to check if the relation is symmetric or not. So let's just check. But again, keep in mind we are working on pairs, so we have to check on the pair basis. That means our symmetric condition will be now that if AB comma CD belongs to R, then CD comma AB must belongs to R. The condition is same for the symmetric, that if AB belongs to R, then BA must belongs to R. But since we are working on pair, we have to take the elements in the pair format. So here I am taking AB as my first element, CD as my second element, and to check the symmetric condition, I just change the order, that is CD comma AB. So let's just check. According to the definition, this give me AD is equal to BC, that is already given in your example. And for this, by using this statement, I'm going to check if this is true or not. So I'm just taking the first element of the first pair and the last element of the second pair, that is CB, according to me, is equal to the second element of the first pair and the first element of the second pair. I'm getting DA. As you look on these two statements, that are clearly visible that these two statements are same. As we know that the multiplication is commutative, CB is equal to BC and DA is equal to AD. So these two statements are same. BC is equal to AD. We can write this as this. So we have proved that the relation is symmetric also. Okay. So we have proved that the relation is reflexive. We have proved that the relation is symmetric. Now let's just check if the relation is transitive or not and what we get. So I hope you understand the concept of reflexive and symmetric, and now we are checking if our relation is transitive or not. So the condition of transitive says if AB belongs to R and BC belongs to R, then AC must belongs to R. But as we know that we are working on pairs, so we will take our element as pair format. So condition will be if AB belongs to R. So if AB, CD belongs to R and CD, EF belongs to R, then we have to prove if AC, that means AB, EF belongs to R or not. We have to check this. So according to this definition, let's put it in the mathematical format. Okay, so my first statement is AB, CD belongs to R. The condition is already given, that is AD is equal to BC. That will be my equation number 1. And my second condition is CD, EF belongs to R. So I have to put it in this. So I'm taking the first from the first pair and the second element from the second pair. That is CF is equal to DE. Here I am taking the second element and here I am taking the first element, and I got this statement. So these two equation I already have, and now I have to prove that if AB, EF belongs to R or not. So we have to prove that AF is equal to BE. So by these two equations, we have to prove this. I think that's not a tough one. I'm just multiplying the equation 1 into 2. So on the left hand side, I will get ADCF is equal to BCDE. What I'm getting, C is C cancelled and D to D cancelled, and I'm getting AF is equal to BE. That's all I want to prove. So the condition is proved and we can say that yes, it is transitive. As we have already proved, the relation is reflexive, given relation is symmetric, and given relation is transitive. So we can say that given relation is equivalence relation. So as you see that how we can prove that the relation is equivalence relation or not, by proving these three conditions, that the relation is symmetric, that the relation is reflexive, and the relation is transitive. Then only we can say that the relation is an equivalence relation. You can see these type of examples in your question paper. Another very common example is on the same set. It's just a little change in your definition, that is A plus D is equal to B plus C. So not a big change, we just change the operation. Here I am performing with multiplication and here they are performing with the addition. So this question is yourself. So try it yourself, and if you can't do it, just let me know in the comment section. In the next video, I will cover it up. Hope you understand the concept, and if you like the video, please like, comment and share the video, and please subscribe the channel. Thank you everyone.